Hey fellow coders, welcome back to our coding journey. Today, we are diving into a topic that adds elegance and flexibility to your JavaScript code, currying. If you have ever wondered about transforming functions, improving modularity, and mastering functional programming, you are in the right place. But before we jump into the intricacies of currying, let's start by exploring a concept that sets the stage for our adventure. Arity. Understanding Arity is like having the key to unlocking the full potential of currying. So grab your favorite coding beverage, hit that subscribe button if you haven't already, and let's embark on this journey into the world of currying in JavaScript. Arity. The term arity refers to the number of arguments a function takes. For example, function fn takes 2 arguments. So it's a 2 arity function, and fn2 takes 3 arguments. So it's a 3 arity function. In the algebra of functions, dealing with functions that take multiple arguments or equivalent one argument, that's an n-tuple, is somewhat inelegant. So Moses, Schonfinkel, and independently Haskell Curry proved it's not needed. All you need are functions that takes one argument and returns another function that takes the next argument. Currying is a technique in functional programming that can transform a function with multiple arguments into a series of functions, each taking a single argument. This not only improves code modularity but also open up possibilities for creating flexible and reusable functions. Today, we will explore the concept of currying through a JavaScript code snippet, starting with a basic example and gradually progressing to a more complex scenario that you might encounter in a technical interview. Let's begin with a simple example to grasp the fundamentals of currying. In this example, the add function takes a parameter x and returns a new function that takes a parameter y. This new function, when invoked with an argument, adds it to x by partially applying the add function with add2 in bracket. We create a new function add2 that adds 2 to any given argument. Now we will explore a fascinating JavaScript question whose solution employs the currying pattern. We will start with a simple example and gradually build up to a more complex scenario. Okay, let's begin with the initial challenge. Here's the question. The goal is to understand how the provided sum function works and how to approach solving this problem. Here's a step-by-step breakdown. The sum function takes a parameter x. If called with no argument, it returns 0. If called with an argument, it returns a new function next. The next function, when called with no arguments, returns the current sum x. If next is called with an argument y, it returns a new function with the updated sum x plus y. To solve this challenge, we need to understand the concept of chaining mechanism of the currying pattern. Each invocation of the sum function returns a new function next, allowing us to chain multiple calls together. In this example, each subsequent set of parentheses represents a new invocation of the returned function, building on the previous sum. Now imagine the interviewer tweaks the question and presents a more complex scenario. How do you adapt our initial solution to handle this? Here's the updated question. As you can see, there are multiple arguments in few of these parentheses. So we will need to modify the sum function to handle both cases, initial invocation with multiple arguments and subsequent invocation with single arguments. We have introduced the use of rest parameters by using ... We have rested args and next args. The sum function now accepts any number of arguments and the next function handles subsequent invocations similarly. The reduce method is used to calculate the current sum by adding up all the values in the args array. The key modification is in the next function, where we check if it is called with no arguments. If so, we return the current sum. Otherwise, we recursively call sum with the accumulated arguments. This exploration into the world of currying has uncovered its elegance and flexibility, showcasing the beauty of functional programming in JavaScript. The understanding of closures, recursion, and ability to adapt patterns to diverse scenarios are key skills for any JavaScript developer. As you continue your journey, embrace challenges as opportunities for growth. Every problem solved is a step forward in your mastery of the language. Remember, the more you delve into this concept, the more confident and versatile you become as a programmer. If you enjoyed unraveling the intricacies of currying, and if you are hungry for more insights into JavaScript and programming, don't forget to hit the subscribe button. Stay curious, stay passionate, and as always, happy coding.